angle which the boy will fall off the wheel can be determined. Okay, I repeat again by using equation number 5. We can determine the angle when the boy will fall off the wheel. Listen, I like this question because I like the way there is a multi-body, okay? Don't treat me like a sadist, okay? He wants the boy to fall. Are we clear? I'm not that evil. I'm Dr. Eugene Ng and not Dr. Evil, okay? So, which value, focus on the boy, okay? Which value will be equal to 0 when the boy fall off? Yeah. Okay. And will be equal to what? 0 when the boy what? Fall off. Okay, so to determine when the boy will fall off, we're going to substitute n is equal to 0 into equation number 5. So finally, so this is 0 is equal to 529.42 cos theta minus 137.024. Theta is equal to 137.024 divided by 529.42 inverse cos 25 degrees. So the boy will start to sleep. Okay, he start to sleep at 29.83 degrees, and then he will roll off. He will go off the wheel at 75 degrees. Are we clear? Okay. This is only true if he don't pee himself. Right? If he panics, start to piss himself, what will happen? Friction will what? Yes, sir. Say it again. It's only the wheel. When we were analyzing the wheel, right? When we were analyzing the wheel alone, oh, that's pretty far back, right? When we were analyzing the wheel on its own, at theta is equal to 0, we just consider the wheel and the boy is not sleeping. Okay. Then later on, we focus on the what? On the boy, right? Because we don't know what is the what. We have not a clue what is the angular acceleration at all. And we know it's not a constant number. Answer your question? Okay, only for that reason. Okay, because it's difficult to determine angular acceleration if the boy starts to sleep. Okay, not impossible, but difficult. Right. A very interesting question. Now, as I said, if you look at your entire textbook, this is the worst that could happen. I repeat again, this is the worst. Okay. Next, we are going to do an example. Okay, now we are going into equation of motion. For general or under general motion. So general motion combines both linear and what? And angular motion. Okay. So the analysis will not change a lot at all, but you just have to be cautious. You just need to focus on how the forces are acting. That's more important. Okay. Right. So we're going to look into this example now. Okay. If P 30 pounds, determine the angular acceleration of the 50 pounds roller. Assume the roller to be a uniform cylinder and that no slipping occur. Okay. This question, okay, is not difficult, but you have to focus on this aspect. Okay, which aspect? So the first thing we declare, no slipping. Okay, no slipping. I.e., where is no slipping, we can use A is equal to alpha R. However, we know that friction force when it's not slipping is not equal to what? Mu n. Okay, so get this into your mind, no slipping. Now, free rolling, there's another condition known as what? Free rolling, right? Free rolling means what? Remember the car, the front wheels were free rolling. What does it mean? Friction is equal to what? Friction force is equal to what? 0. Free rolling, okay, I'll write down here. When it's free rolling, FF is equal to 0. In real life, is there free rolling? No. Okay. We do free rolling is to what? Make the what? Analysis what? That's it. But all the structure that we analyze up now require what? Rigid body. Yes or no? You know, I know that is not always the one. Okay. But that will simplify our what? Analysis. A very good one. Approximation. Are we clear? Okay. Now, for this case, the problem, all of a sudden look at this. Hey, Eugene, it looks easy now. It is easy. Easier than the boy rolling off the wheel. Yes or no? Right? So it's not that bad. But what is bad is this. The free body diagram. Okay. So we are going to look at the free body diagram. Right? So we know at the center over here, I will call our point G. And this is going down. And this has what? 50 what? Pounds over there. Okay. And over here, we have a reaction. And our reaction is N. And then we have a load coming down over here. And this is equal to what? 30 pounds. Friction force. Directly. Friction force. Which directly? Huh? Friction force was the right or friction force towards the left? Ah! The textbook is as confusing. Okay? I'm very infamous of making my own rules. Those of you that have done 303, you will know that. Okay, 303, all the formula in the textbook, what happened? We threw up the garbage can. You have to what? Visualize. Now I'm going to ask you a question. Let's do something physical. That's why we are mechanical. We are going to push the car. Right? We're going to push the car. Is the friction going against us or helping us? I repeat again. Now, no rocket science, yeah? No rocket science, yeah? You push your car, right? The friction force is going to help you move the car or help you stop the car. What is it? If you never push the car, now we go up to my car and I make you push my car. I follow you in my car and we push. What is it? The friction force going to go against you. Yes or no? Okay. Then some of you are like, oh, for fuck's sake, Eugene, I'm confused. Wait, I will unconfuse you. So we know now, this is the what? Friction force. Agree or disagree first? You agree. Sorry, now is my dictatorship coming in. You have to agree. Sorry. I do apologize, okay? I cannot treat you all like my daughter. Oh, I pity my daughter. Right? So when I push, the friction will go against us. Right? There's no way that you push, the friction will help you. Physically impossible. Then now you did. You will say, you did, for fuck's sake, you got something wrong. What did I got wrong? Okay. If we look at, when did we do the broom? Wait, when did we do the car? Can you remember when we do the car? The day you gave me problem, where are you? Is it on the 13th or where? Week 13, is it? Oh, November. Yeah, thank you. You telling me. Yeah, jawohl. Wait. So for this case, let me, I hate this, okay? Okay. For this case, right? The car is going this way. Yes or no? This is the motion of the car. However, friction force is together with the motion. Now we say, Eugene, I'm really confused. Friday, 5:30, you have not given us a break. WTF is happening. Yes or no? Why? For this case, how is the car moving? What propels the car? The engine is propelling the car, and the engine is driving the what? The wheels. Which direction is the torque? So now we have to bloody look at the wheel now. We have to look at the wheel now. Okay. So now we look at the wheel. Okay, we zoom in. Come on, Eugene, draw a better wheel than that. Everything is circle. The wheel has to rotate in this direction for the car to go forward. Agree or disagree? Yes or no? If the omega is that way, torque is in this direction. Agree or disagree? When torque is in that direction, you know torque is equal to force multiplied by what? Radius. Which direction is the force? So when the direction of the force is that way, what will happen to here? Are we clear? So when, remember in class,